Hi, welcome. I'm doing this video for CAS IB stuff. I'll be teaching chemistry because I can and because I want to. Hopefully this should count as CAS. I mean, it's free education to anyone who has an internet connection. I actually don't have any better applications, drawing applications, I mean. So we're gonna have to resort to using Microsoft Paint. Uh, so today, we're just gonna be learning about something called chemical nomenclature. Here, let me type it for you. So, in case you don't know how to spell it exactly, uh, so this is the science of naming chemical compounds. See, there's like certain set of rules that you should follow when naming these kinds of things, and it's a really big part in organic chemistry, which is a subject we'll be learning at my school after thermodynamics. So I guess this video could be helpful in a way. I mean, other people can watch it too. Uh, so, oh yes. Before we start, the dog always has to be in the video. I'm sorry, it's just a habit. It's just a practice, a tradition that I must fulfill on this channel. Just because I like the dog and I want it everywhere. Okay, just get the proportion right. Just how do you? Okay, 80. There we go. Get a bigger space to work with. You're moving to the bottom right corner. Yay. I don't know. The dog kind of serves its purpose in its own way. Guess you can look at it whenever you feel bored. And then of course you can look back to me if whenever you're not feeling bored anymore. So I guess we'll just start with the most simple beginning to all this. So we're going to be learning about how to name alkanes, alkenes, and alkynes. So it's just alkane, have the alkene, and let's have the alkynes. So these are chemical compounds that are made up of carbon and hydrogen. And for alkane, these carbons are single bonded with other carbons, while in alkene it's just the same thing, except we have at least one double bond present in whatever CH molecule we have. So for the alkynes, we have another CH molecule, but this time with a triple bond. Just pay attention to like the back part of this. So let's just draw an alkane. Just give you an example. So like this is what normal alkane is. Just a real simple one. So the carbons should be bonded 4 times, while the hydrogen should be bonded once. And you can find this out if you look at the periodic table and see how many more electrons the carbon needs and the hydrogen needs to reach the octet, or basically the rightest part of the periodic table. So carbon 4 times, hydrogen once, and everything is satisfied. This thing is made up of carbon, it's made up of hydrogen, and it's a single bond. So for alkene, it will be like this. So double bond, which basically makes this an alkene. It's also made up of carbon and hydrogen too. Since this carbon is double bonded, you can only accommodate 2 more bonds, because 2 plus 2 is 4. So you only have 2 hydrogens on each side, which gives it C2H4. Well, this is C2H6, and this one will only leave 1 more space, and we get the C2H2. Okay. Hope you got all that down. So there's a specific set of rules that you need to follow when naming these compounds. I guess I'll just draw a table. Hopefully it will help. So we have the alkanes, which we'll just put the back part here. We'll have the alkenes and the alkynes. So the way that we name them is we basically have to count the number of carbon in whichever molecule that we wish to name. So if we have 1 carbon, we have a prefix for that, which is called meth. Similarly, when we go down and increase the numbers, each of them has their own associated prefix too. So I'm just gonna write that down all for you. Now 2 is F, 3 is prop, 4 is but, 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, I think, and 10 is dec. Of course, it goes down. There are specific prefixes for 11, 12, and so on, but it'll just go on to infinity. I'm not writing that down. So basically, if the compound that we're looking for is an alkane, meaning it has a single bond, and it only has 1 carbon compound in it, you call it a methane. It's just simple addition, meth plus ane, methane, and I'll just draw it for you. 1 carbon, and then just fill out the rest. Hydrogen should be here like this, and this is your methane molecule. So basically, it's just really easy. You just have to remember all this thing here and all this thing here, and you can start naming. So let's try to do another one. Let's do an ethane. So if I ask you to draw an ethane, you can know that it's carbon molecule with 2 carbon pieces, and that they're single bonded with each other. That makes this image right here, and just fill out the rest. like that. So let's try another example with alkenes this time. So if I ask you to draw a propane molecule, for example, so it would be 3 carbon pieces. So just 1, 2, 3, and at least 1 double bond. So we just have to put at least 1 double bond there, and it can already be considered as an alkene, and you just have to fill out the rest. Hydrogen here, here, 1 here, and 3 here. Really cool, yeah. So I think after this last drawing, we're gonna be switching to a simpler way of drawing, especially as we reach the carbons with long numbers. So we can also try to draw using this way. I'll use the same example. So we can represent the carbons as long sticks like this. So where each end or each corner represents a carbon compound, the hydrogens aren't included for simplicity, while this one line represents a single bond, and whenever you want to draw a double bond, you just have to put another line there, and that can signify for a double bond. So propene will simply just be like that, while an ethane is just one stick, one carbon here, one carbon here, and single bond, while ethene will be a stick, 2 sticks, one on top of each other, one carbon here, and they're double bonded, ethene. So really useful, really quick, lazy, easy way to draw, especially when we're trying to go down towards these really big numbers. So as you try to draw the alkanes, I think it's important to notice a certain pattern here. So methane is just 1 carbon with 4 hydrogens, while ethane is C2H6. And notice, because we've drawn this before, this should be C3H8, because 1, 2, 3, 4, 5, 6, 7, 8. So it's like pretty useful to, if you notice the pattern here. Specifically, when you go down, you add 1, while the hydrogen goes add 2. So you can easily predict the number of carbon and hydrogen without even memorizing a single thing. So really cool, see? C9H20 and C10H22. Cool. Let's try to draw a decane just to see if this pattern is correct, just to prove to you, I guess. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 1 carbon here, 2 carbon here, 3 carbon, and so on. This carbon will have 3 hydrogen. You'll have 2, 2, 2, 2, 2, 2, 2, 2, 3. So how should we count this efficiently? 1, 2, 3, 4, 5, 6, 7, 8, 8 times 2 is 16. 16 plus 6 is 22. See? Yeah, that's right. So that's a nice pattern to keep in mind. Similarly, the other types of carbon chains, such as the alkenes and alkynes, also have a similar pattern. You can't draw a methane technically because you only have one carbon, and it's impossible to have a double bond because hydrogen can only accommodate one bond. So it should actually be a blank space for here. Also the ine, because you need 3 carbon, a triple bond. Yeah. So there's nothing in here too. So the ethene will be C2H4, as we've seen before. The propene will be C3H. I actually forgot. Hold on. 1, 2, 3. 1, 2, 3, 4, 5, 6. 6. Go C4. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. H8. So basically, it's the same pattern. Each carbon adds 2 hydrogen. Each carbon adds 2 hydrogen, and like all of the hydrocarbon chains follow the same thing. So again, you can easily predict all of this down just through simple patterns and such. The alkynes will be C2H2. This one will be C3H4. Let's test that out first. 1, 2, 3. 3 carbons, one of them is a triple bond, so 1 hydrogen here and 3 hydrogen here. 1, 2, 3, 4. See? So the only difference between them is the amount of hydrogens that you start with. So in ethane you start with 6, and as you move on you decrease the hydrogen by 2. So from 6 to 4 to 2. So the starting hydrogen is smaller. So this is how you can tell if something is an alkane or an alkene or an alkyne. Because you see, if we have C3, this should be H8, while this one is C3H6. So you know, because the hydrogen, if it's less, in this case 6 or in this case 4, then you can easily tell if something is an alkene or an alkyne based from the number of hydrogens here and here. You can notice the decrease in 2 as you hop from here to there. So lots of patterns. If you can exploit them, that's really well. So I mean, yeah, I guess you can name like everything in this box, probably. I mean, pretty self-explanatory, this table. I mean, if I ask you to draw heptene, it's just 7 carbons, 1 double bond. So just give you one final example before we move on. So 1, 2, 3, 4, 5, 6, 7. 1 double bond. So really easy. 2 hydrogen here, 1 hydrogen here, 2 here, 2 here, 2 here, 2 here, 3 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And you can easily check this out. Ethane has 6 hydrogens, so we go from 6, 8, 10, 12, 14, 16. Wait, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Am I doing this right? Wait. 1, 2, 3, 4, 5, 6, 7. C2H6. Oh, wait. C2H6. 1, 2, 3, 4, 5, 6. Oh, we're talking about alkenes. I'm so dumb. Okay. Yeah, see, so if it's an alkene, you can easily tell because 16, you hop here, minus 2, that's 14. That's exactly what this structure shows, so you know it's an alkene. Yeah, this proves my point, although I did show my stupidity. God. Hold on, I need to drink some water. Talking is really difficult. I keep my bottle with me every single time. See? Next part. So we can get even more complex. Say we want to draw something with multiple double bonds, perhaps. So I'll just show you an example of what that would look like. See? So something like this has 2 double bonds. And we also have different example, which is carbons with double bonds and that they have different placements. So you can see that the double bond is placed in the middle, while over here the double bond is placed along the edge. So these two are different from each other, and this one is also different from each other. But if we were to use the previous table before, it wouldn't help to separately identify all these three, because 1, 2, 3, 4 carbons, so that's a but, and 1 double bond, which is an ene. So basically, if we were to use this system, all of these would be butene, but they're not all the same. I mean, like, look, they're not the same. So we also have to introduce like a different set of rules if we want to overcome these difficulties. So just get rid of these arrows. And let me think for a while. Okay, we'll start with the positioning. So whenever you encounter double bonds which are in different positions, the way you differentiate them is through the use of numbers. Yeah, sorry about that. I live with someone else. Hopefully you can understand. This looks like a triple bond. It shouldn't be a triple bond. What was I saying? Yes, okay. Each of these carbons have numbers. So this is the first carbon, this is the second carbon, this is the third carbon, this is the fourth carbon. It's just read from left to right, or you can even also read it from right to left. There will be certain conditions or certain situations rather wherein the reading from left to right will be better than right to left, or when the reading from right to left is better than left to right. So we'll just show you a couple of these situations just so you can understand, hopefully. So since it is this carbon that contains the double bond, the second carbon right here. Yeah, again, sorry for that. It's unpreventable. I'm sorry. Uh, I keep getting interrupted. Jeez. So we are supposed to put the number before the in. So we call this one the but to in. So this basically means that we have carbon hydrogen molecule, and this has 4 carbons. We know this from the but. We know that it has a double bond. We know this from the in, and we know that the double bond is at the second carbon, which is right over here. So if we were to read from right to left this time, this is C1, this is C2, we'd also receive the same name because this carbon has double bond, so it would still reach the same name. Understand? Yeah. So over here we could call this one as but one in. This is because the carbon is placed in first. The double bond is placed in the first carbon. Yeah. But usually, if you have number 1 in here, you can easily cancel that out and just write butene, because people will normally assume that the double bond will be placed in the first carbon every time you don't include the number here. It's just the default setting or option. So you can see that if you were to read from right to left, this will be carbon number 1, this will be carbon number 2, this will be carbon number 3, this will be carbon number 4. Technically, but 4 in will be the same thing as but 1 in. The only reasoning behind this is just that we never use but 4 in for writing, because although they're technically the same, we only use the simpler forms. That is, the names which involve the lowest number. So if you have the option to write something with 4 or with 1, the better, not better, the correct option is to use 1. I don't think you would even get marks or credit if you were to use this instead, although technically it's the same thing. So another thing I want to address before we move on, just have to delete, please wait, is what if we have something like this. Now just look at this, number 1 and number 2. Are number 1 and number 2 the same or not the same? I mean, this one is here and this one is over here. So, I mean, some of you might not know if they're the same or not, but they are the same. That's the answer. Well, this is because like you can just easily rotate this structure. You have to like understand that these chemical compounds, they're like 3D, so like you can obviously rotate them. So if you were to just do this and do this, and see, now they're the same thing. I mean, like the carbon is letter is mirrored, but like in the chemical world, these are just like balls. So I mean, like you can see that these two structures are the same thing. So the answer to this might have been obvious, but sometimes we'll encounter different structures, more complex structures, and the answer might not be that obvious. So like one way you can identify if the chemical compound is identical or not is to actually try to name them. So that would be a valid method if you want to try to identify if two different molecules are the same. Just try to name them and see if you achieve the same name for both of them. So we know that this is but one ene because this is from the first carbon. So if we were to try to name this one now, we would have 1, 2, 3, 4, but we could also have 1, 2, 3, 4. Like I said before, we have to pick the lowest number, so I'm going to go with the 1 to describe this carbon's double bond. So let's start. How many carbons? 4. So it's but. It's a double bond, so it's an ene, and it's at the first carbon, which is 1. So this name and this name is the same. So even though the carbons might seem like they're in a different position, they are actually the same chemical compound. So that's a nice thing to know. So we talked about the positioning already, and I guess just show another example, I guess, just to help. So what if we have something like this? We'll just give you, I don't know, 30 seconds to name it, I guess, while I drink. So do whatever you want to do. It's not obligatory. I'm not forcing you to answer it or anything. But like 30 seconds, just do whatever you want while I drink. So you probably have your answers by now. And hopefully it's right. Because if it's right, it just means that I'm a great teacher. And I want to know that I'm a great teacher. So let me just solve this real quick. 1, 2, 3, 4, 5, 6, 7. So that's a hept. And it's an ene. So we take the least number. So we have to go from right to left because that will give us a shorter number. So carbon 3. So call this molecule hept 3 ene. Hopefully you're right. Because if you're wrong, that means I'm doing a bad job at teaching, which beats the purpose of this video. Let's talk about this one now. What if there's multiple bonds? See, I got one double bond here and another here. So to signify if you have a double bond or not, we have to put prefix, which is a word before this "-ine", because this "-ine" means a double bond. So if you were to write "diene", it shows that there's two double bonds. And this will just go down. Triene shows that there's three double bonds. Quadene will show that there's four double bonds, and so on and so forth. So the numbering system over here is different than the numbering system for the carbon. I think most people will get that part switched up somehow, like they're just gonna say diane or something maybe, which is wrong. So just try to at least like realize that we're dealing with separate numbering, how do you call that? Separate numbering methods for the amount of bonds present and the amount of carbons present. You don't want to get them mixed up, especially in tests and exams. So if we were to talk about this specific molecule, we would say that it's called a butadiene, except there are actually multiple butadienes. You see, these double bonds are placed one on each edge, while there are actually multiple placements, which I'll show you right like this. So now that these two double bonds are placed next to each other, and like you can easily see that this one is different from this one. So we have to apply what we learned from positioning to correctly name this compound and this compound. So we just do what we've learned before. So carbon numbers, yes. 1, 2, 3, and 4. So carbon 1, carbon 2, carbon 3, carbon 4. I just repeated myself. So this should be called but 1 to indicate that the first double bond is in carbon 1, and 3 because the second double bond is in the third carbon. We don't use 4 because that's a higher number. We can use 3, that's easier, that's more practical, that's the correct way. So but 1, 3 diene. Again, what does this mean? But 4 carbons, diene, 2 double bonds. One of them is in the first carbon and over here, and the other one is in the third carbon over here. I actually want to check for a while to see if I'm actually recording. Yes, I am actually recording. It would have been terrible if I wasn't actually recording, because I'd look incredibly stupid. So let's just delete the space for now. So let's try to name this one now. Let's try to number it left to right. 1, 2, 3, 4. 1, 2, 3, 4. So you can identify that the left to right numbering works better because we're dealing with smaller numbers. This one and this one especially. So we call this compound, following like the previous one, 4 carbons, but 2 double bonds, diene. They're from the first carbon over here and from the second carbon over here. That's 1, 2 diene. So different names, so different chemical compounds. This is not the same as this, and we can prove that by trying to name them and finding out that they have different names. So like we've been doing with alkenes all the time. So actually, the same principle should also work on alkynes, which are the triple bonds. So let's show you another example. So this one would be called but diene. We're just following the rules from the previous examples. So but 4 carbons, diene, 2 triple bonds, I'm sorry. More water. Again, the naming principle is the same for alkynes. First carbon, second carbon, third carbon. First carbon, second carbon, third carbon. So left to right, right to left doesn't matter. We have this carbon here and this carbon here, 1 and 3. We have this carbon here, and we also involve this carbon here, 1 and 3. So they're the same way either. So we call this, you just have to include the numbers to be specific with the position. Put 1, 3, diene. It is a 4 carbon containing hydrocarbon with 2 triple bonds. One of them is located in the first carbon, one of them is located in the third carbon. Easy. So let me just give you an exercise. Name this for me. I'll give you another 30 seconds while I drink more water. I think you should be done by now. Let's just solve this real quick. First carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. This is a hex diene. There's 2 double bonds. Which numbers are we going to use? 1, 2, 3, 4, 5, 6. So if we were to use left to right, you'll have number 2 and number 4 here to represent these double bonds. Let's try right to left. 1, 2, 3, 4, 5, 6. It's the same. Second carbon here for this double bond. Fourth carbon here for this other double bond. So we'll be using 2 and 4 either way. So correct answer is hex 2,4 diene. Again, hopefully you got this answer right. I don't know what else to talk about. Let me think for a while. Yeah, okay. So, what if you have a carbon chain that is connected with another carbon chain? Let me just draw this for you. Okay. So we have one chain over here, and what happens if we attach another chain, like so? So how would you name this chemical compound? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This C4H10 compound. How would you name it? So the first rule that goes behind naming this kind of compound is to look for the chain with the longest carbon. So the longest chain here is these three, while this is just a short attachment. So we'll start by naming the main branch, which is this one here. So we know that this is just 3 carbon. That makes it a propane. Also because single bonds, so ane right there. And there's no specific numberings that you need, so it's okay if you don't include numbers here. So right now we'll be using something to describe this addition here. I'm trying to remember, give me a few moments. I actually forgot, my goodness. Let me search the internet for a while. Okay, so you have the main branch here. So you name the main branch first. I'm sorry again. So to name the additional branch here, you just have to identify the length of this carbon chain here. Since it's only one, we use the meth counter, which shows that it's 1 carbon. So we call this as methylpropane. This shows us that this propane is connected to 1 methyl group, and this is what the image shows. We have a propane here and a methyl here, and they're connected to each other. So the name basically acts in a similar way. Methylpropane, a propane with a methyl attached to it. So if we were to try to attempt to number these carbons, we would see that this methyl group is attached towards the 2nd carbon over here. So we also have to include that in the name. So in the end, we'll just have to be 2-methyl propane, and that's just a more technical term. If you want to be specific with the numbering, You will have to be specific with the numbering if you're dealing with longer chains that have many different possibilities. So this 2-methyl shows that the methyl is in the second carbon of the propane. See, everything just matches each other. So we have a propane molecule, 1, 2, and 3, and methyl on the second one. So that's how you name multiple branched carbon compounds. More examples, so to make sure that you understand. So let's say you have a longer chain here, and you have one methyl here and another methyl here. So it's pretty easy to identify the longer chain. It's this one right here. Just count 1, 2, 3, 4, 5, 6. It's hexane. So a similar principle will happen if you have multiple methanes. So just like how we count the bonds with like alkene and alkdiene, alktriene to show the different numbers of bonds, we also use the same numbering to identify the different numbers of methyl groups that are present. So we have 2 methyl groups here, that makes it dimethyl. Specifically dimethyl hexane. So we know that this hexane has 2 methyl groups attached to it. Right. And again, numbering system. So I think we can go left to right. So it's in the second carbon and the 4th carbon. Yeah. So it's 2,4 dimethyl hexane. So if this carbon were here instead, that would have been 3,4 dimethyl hexane, and so on and so forth. We can also combine this with multiple bonds. So let's say this hexane actually has a double bond here. We can simply just change the suffix of the hexane, this last part here. We're going to change it to "-ene" because one of these have a double bond, which basically turns the alkane into an alkene. So we call this the 3,4 dimethyl hexene. So if this carbon double bond were to change position, say on this side now, we would say 3,4 dimethyl hex 4-ene. So this 4 and this 4 corresponds to the 4 from the methyl group over here, and the 4 over here in the hex 4-ene will show that this carbon, number 4, will also have double bond. See? So you can easily just connect all the rules together so that you can start to name even more complex compounds. So, I mean, these rules are can be easily mixed and matched together, basically, depending on the complexity of your compound. You can double bond, just put "-ene", different position, just put number, different numbers of bonds or different numbers of attachments, you just add di or tri, and that's basically the whole concept behind chemical nomenclature. So another important thing which I think you should note is these tricky questions which you might encounter. So how do you name this compound? If you were to go by your usual instincts, probably you would immediately look at this thing here and say propane, 3 carbons, single bond, propane, and you'd look at this and you'd be like, that's an ethyl group because 2 carbons instead of 1, like the methyl group, because 2 carbons. So you would probably, maybe I'm just guessing, immediately assume, oh, that's just ethyl propane. But the thing is, I said earlier, this is a trick question. This is not ethyl propane. Woo, plot twist, mind blowing. So like, this is a trick question. This is because you would be wrong if you followed this approach from the very first step, which is the identification of the longer carbon chain, C chain. These 3 carbons are not the longer chain here, because you see, if I were to draw this, highlight this area here, maybe I should do it with a different color. If I were to highlight this area here, you would notice that all these 4 carbons are connected, and that provides us a longer carbon chain. So unlike before, where we have 1, 2, 3, and 3 over here, if we try to do the same thing like we did here, these 3 carbons are connected in a whole line like a chain, it's still 3. So if we were to do the same like this over here, it's still 3. If we were to do it this way in this line, it's still 3. So like, it's very easy to identify the longer chain here, no matter where you look or how you look, because all of them will provide the same answers. But when things start to get more complex like this, you have to think harder to identify the longer carbon chain. Just like draw a line or something, and then you'd be like, yeah, 4 carbons, so that's the longer chain that you're dealing with. Yeah, real tricky, real annoying. So how to properly name this now? Now that we have this line, this L, this inverted mirrored L to deal with, we'll start with naming these 4 carbons, and that's easy. Should I change color? Yeah, it's Ethane. 4 carbons connected to each other by a single bond. More water, sorry. I'm not used to talking this long. Butane with 1 methyl group. So, methyl butane. So, let's try to draw this better so we can work with the numbers. So, butane is just 4, and like, it's like should be somewhere here. So just notice that you can rearrange earlier structure into this structure, which is more easily understandable. So this structure can be converted into this structure. So we just have to, you can easily visualize it by looking at this structure sideways. Then you can see that these four are connected with one carbon attached. I hope you're turning your head sideways, otherwise it will just make no sense. Again, I'll just repeat. 4 carbons here with one attached, one before the end. So same thing in this side here. It's just 4 carbons here, one thing attached, one methyl group attached before the end. So like this carbon could be placed here instead. So they're really just the same thing. This and this. It's just different perspective. Whether the carbon is placed this way or this way, directly next to it or directly under it, will lead to different changes in perspective. So it's important to notice these kinds of things while you're doing work. So another exercise, the third one of the day. I don't know how long this video has gone on. It's really long. So name this for me. I think this is going to take a longer time, so I'm going to use this advantage and go to the toilet, pee break. When I return, I think you should be done. I hope you should be done. Hi, I'm back. I have to do something first. You have more time. Hi, I'm back. Oh yeah, should have been done naming this. Maybe. Longer chain, yes. So different colors. So we have two options, I think. U and U. So just count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They're the same. So 5 carbon, that's a, hold on, I almost forgot, pentane, yes. Pentane group. So you know that the rest of the carbons, which are these two here, if you're looking at the red context, or it should be these two carbons here, if you're looking at it through the black context, if you know what I mean. So either way, it's 2 carbon attachment, meaning that it's an ethyl pentane with an ethyl group attached to it. So the next thing you should identify is the numbering. So if we were to number, let's start with the red context at first. 1, 2, 3, 4, 5. Just follow the line. You would know that the ethyl group, this 2 carbon, is attached with the 3rd carbon of the pentane. So it's 3 ethyl, because that's how the rules work. 3 ethyl pentane. Pentane with an ethyl on the 3rd carbon. That's how you read it. So if we were to use this black context, the numbering would be 1st carbon, 2nd carbon, 3rd carbon, 4th carbon, 5th carbon. So again, it's just the same thing. 3rd carbon, and on the 3rd carbon we have this ethyl group, this green circle right over here. So same answer. Doesn't matter how you look at things. Pretty cool. So one more thing to talk about, I think, which is what if you have both a double bond and a triple bond in a single chain. So I'll just give you an example. Ta-da! So you have a double bond and you have a triple bond. So how do you name this? Well, I'll just tell you in a while. So again, start from the very basic, simple points. 1, 2, 3, 4, 5. It's a pentane. Well, not a pentane, it's a pentene, but it's also a pentyne. Okay, so this part gets really tricky. Next, numbering. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So this will mean carbon 1, carbon 3, while if we look at it left to right, it will be carbon 2 and carbon 5. So I think 3 and 1 would be the better choice here, because these numbers are more smaller than simple compared to 2, 5, 3, 1, and 2, 5. I mean, if you add them up, it's just 4 and 7, so 4 is simpler. Yeah. So we have to first identify the positioning. So we have to first notice that the first carbon is a triple bond, which is an ion, while the 3rd carbon is a double bond, which is an ene, like that. Yeah. What's next? Yes. So forget this part because it's definitely not another pentane. So first we have to this part stays the same because number of carbons stays the same. So we have to address this thing here, this double bond here, and this triple bond here. So pent 3 in 1 ion. Yeah. So this is how you name something with a combination of double bonds and triple bonds. So we can reuse this suffix, I think. Like suffix is the last part of the word while the prefix is the first part of the word. So we can repeat these suffixes. So one of them to show that, hey, this carbon molecule, this 5-carbon molecule has a double bond, and then you repeat it. Hey, this pentane, this 5-carbon molecule also has a triple bond. So you know that it has a double bond and a triple bond, and you know that this double bond is located in the 3rd carbon, hence pent 3 in, and we also know that this triple bond is located in the 1st carbon, which is 1 ion. So in total, this is how you name it. You just have to repeat what the rules say. There's double bond, you say in. You also have to specify the position. There's a triple bond, you have to say ein. You also have to specify the position. So that's how the rule works here. So just pent 3 in, 1 ein. And that's what you call this compound if you ever need to call it. With that, I think everything should be done. This video took way too long. And notice, by the way, that we've only covered 2 elements out of the hundreds that are on the periodic table. And I think this video has lasted for more than an hour already. So you can see the vastness of organic chemistry, or just basically chemistry in general. So that's the end of chemical nomenclature tutorial part 1 ? I'm finished here. I think hopefully you learned something new. Otherwise, my time here is useless. I wasted my time and you wasted yours. So hopefully I've been helpful one way or another, and you've learned something new. Bye.